Now that we know what data is and how we can classify it, we're going to talk about how we collect it with studies. So first thing we're going to talk about here are the ways that we should be looking to design a study, where we have essentially 6 steps. The first one is essentially to think about what we're trying to do, where what we have to do here is identify the variable, the thing that we're trying to study, and what it is that that thing is a part of, who it pertains to, who the population is that will be represented by our study. Then, once we have our pieces, we make a plan for how we can get access to that data, how we can find and measure the variable, how we can get members of the population to participate in our study, however we're going to be studying, which we'll talk about later. Then, once we have our plan together, we actually do the work. So most of what we're going to be seeing here today is concerned with these steps, and especially step 3, where we are collecting the data that we're going to be working with, whether that means we're drawing numbers or taking responses, what have you. This is what we're looking at with collecting data. Then we're going to describe and interpret it. Like I said, the distinction between descriptive and inferential stats is kind of moot, because usually we want both, where we're going to be making our data look nice, and then we're going to be using that nice looking data to sell some idea. And then once we have all that, we have to actually make sure that what we did is reasonable and in some sense accurate. Hi, a quick interruption here from while I was editing. It looked like I kind of glossed over the bit about checking for errors in designing a study. And that's the sort of thing that usually kind of gets glossed over when people are trying to run an experiment or what have you. It's a bit of a thankless job to go back and check, but it is actually very important in the scientific process. And it's a big part of what gets put out is people going back and making sure that the results are as meaningful as they think and that there weren't mistakes in the design or execution. And in this class, we don't talk as much about that stuff because it doesn't really fit the model for what we go for. There isn't really a nice multiple choice question I can ask you about error identification that really gets at why this stuff matters. But when it comes to these sorts of things, just bear in mind that a poorly designed or poorly ran or in some way incorrect study is at best accidentally helpful and at worst outwardly and obviously harmful. And we can see the effects of that latter case in a lot of different places. So even though we're not going to see it much in this class, I do think it's worth spending a bit of time here just reiterating the value of step 6 there, because it's kind of easy to lose track of. Anyway, back to the rest of the video. Where when we're doing this, we have to be sure that what we're doing is fair, we're getting a valid representation, and what we have is reasonable to what we're trying to find. And that's really what we're going to be spending a lot of time talking about today, is how we can do these things in a reasonable way, what our options are, how we may want to approach these types of situations. And we're going to start that conversation by looking at the ways that we can actually get our data. We're going to start with step 3.